So, Jayant, hello.
Yes, ma'am.
So, can you give me the brief introduction of yourself?
Yes, ma'am. Good afternoon, ma'am. Myself, Jayan PK. I completed my BE in Electronics and Communication from East West College of Engineering, Bangalore. And I also completed my PG diploma course in VLSI Design from IIIT, Bangalore. During my course, I work on project on 32-bit Vedic multiplier and dual port RAM verification. My skill include digital electronics, Verilog, system Verilog, and basics of EVM.
So, where you have done the verification of dual port RAM?
And PG diploma course, ma'am.
Okay, so you have built the UVM environment in that.
Yes, ma'am.
Okay, so can you explain your project,
Project, ma'am.
this dual port RAM using system, like how you have created the UVM environment and how you have
Like
taken?
work
Yeah.
on system Verilog, ma'am, not UM.
Okay, okay. So how you have verified? You can you explain me how you have
I'm,
verified the dual port RAM?
first flight design code design and interface, ma'am. And in the test pen side, first generator, uh, first transaction generator and driver, monitor, scoreboard, environment, test, and top codes, ma'am.
In system Verilog you have done, right?
Yes, ma'am. Yes, ma'am.
So do you know the UVM concepts?
I know basics of UM, ma'am.
Can you explain me that? Like why we use the UVM?
Uh, UM is a methodology, ma'am. It's it's like a like a format, ma'am. How to run and it extend the components like objects, ma'am. It have phases and in IBM I use create instead of new constructor we use create, ma'am. To it helps to override factory override, ma'am.
What you have said in the last line? Okay, okay, leave it. So you have implemented the generator, driver, monitor, and scoreboard manually.
So,
So can you explain me the what is generator, driver, monitor, and scoreboard?
a generator helps to generate stimulus, ma'am. And driver drive the stimulated inputs to design through interface, and monitor collect the data from the DUT through interface, and um, send it to scoreboard have checker which check the output is correct or wrong.
Okay. So what is the interface?
Interface say, signals in between test bench and DUT.
Okay. So you have done the dual port RAM. So what is you meant by the dual port RAM?
It's a it's a RAM which has two port for read and write operation. It simultaneously it can read both read and write operation take place, ma'am.
Okay. So you have so in your course there is only system Verilog or
The,
you have the UVM also?
they thought basics of PM only, ma'am.
Okay. So have you thought about creating it with UVM environment?
No, clearly not, no, ma'am.
Okay. So which HVL did you use and why?
Ma'am,
So why you use the system Verilog, not the Verilog?
so use the system builder, ma'am.
Why you have not used the Verilog?
I mean, verification, Verilog is a system. I use Vistamella because Vistamella is for verification purpose majorly because it have constant randomization and assertion coverage and OOPS concept is advanced concept used in system Verilog and yes, ma'am.
So if I want to use the one class of objects or components to other class, so what we can use for it?
Ma'am, if we
If we want to use the objects or components for one class to the other class, what we can use in OOPS concept?
I mean, it's inherit properties or nesting, ma'am.
Yeah. Okay. So what is the inheritance? How
Inherits and
declare the classes?
inheritance declared using the extends keyword. It it inherits the property of the base class, ma'am. It's
So
also
what
called
are
as
the
subtrusting.
name of the classes? Like what we call in general form?
Then the parent class and child class.
Yeah. Okay. So
Child
how do
class
you? Okay.
child class inherits the property of the parent class, like class child extends parent.
Parent class inherits the property of child class.
Child class child class inherits the property of the parent class, ma'am.
Okay. So how do you verify the parallel read write
How
in
do
your
you?
dual? How do you verify the parallel read write in your dual RAM?
Re- I mean, it has two ports, ma'am. Parallelly, we can read and write operation and take place simultaneously, ma'am.
Mm. So did you use the assertions?
And no, ma'am.
Do you know what is assertion? Or
Yes, ma'am. Its assertion is for early detection of bugs and it's run in observed reason.
mm, can you repeat?
Assertion is used to early detection of bugs. It's run in the observed reason.
So do you know about the regions in system Verilog and Verilog?
Yes, ma'am.
What are they? Can you define like what are the
Um,
regions?
in Verilog, there are five reasons, ma'am. Postpone, active, inactive, NBA, and postpone, ma'am. In prepone region, sampling of data will happen. In active region, all the continuous assignment and blocking assignment and RHS side of the non-blocking assignment and dollar display, $8 operations will take place. In inactive region, hash zero delay statements will execute. In NBA region, updation of non-blocking assignment will execute. And in postpone region, dollar monitor and dollar strobe will be execute, ma'am. In a system Verilog, there are nine reasons, ma'am. Prepone, active, inactive, NBA, observed,
Sorry.
reactive, re-inactive, re-NBA, and postpone reason, ma'am. And first four reason, module and module block will execute. In observed reason, execute in assertion, ma'am. In reactive, uh, reactive, re-NBA, execute program block, ma'am.
So do you know about the coverage?
Coverage two type code coverage and function coverage, ma'am.
Can you explain them in detail?
Code coverage means in design code, how much line code is executed out of a, for example, if 100 lines of code is there, how many lines of the code is for example, if the 100 line code, it takes 90 lines code, ma'am, it's a coverage percentage 90%. That's like code coverage will execute. Functional coverage means in generate stimulus, how much percentage of the uh, where value field is just generated and executed, ma'am. Check the function of coverage, ma'am.
Okay. Do you know about the immediate and concurrent assertions?
Yes, ma'am. Immediate assertion means uh, in that cycle it execute, and means next cycle will execute, ma'am.
Okay, in immediate, I think checked once at a specific time,
Yes, ma'am.
and in concurrent, it checked after the over the simulation time,
Yes, ma'am. Yes, ma'am.
usually for the sequences.
Yes, ma'am.
Okay, so can you write? Know how to write the assertion.
Yeah, yes, ma'am. I know, ma'am.
So please write an assertion for the read after write in RAM.
For RAM, ma'am.
Yeah, read after write. Condition will be read after write. Assertion, please write.
I don't know for the RAM, ma'am. Basic
No, you just have to write the condition only.
condition.
You just have to write the condition only that we have to read after write.
And design code, ma'am.
Yeah.
In book or not?
Okay. Think that our design code is RAM only. So
In book or memory? No, not from screen share. Can I write in book, ma'am?
yeah, in which you are comfortable. If you want to write in notepad or in copy, your choice.
Hmm?
It's not visible.
No,
No,
ma'am.
no, it's not visible. Um, I think you have done the portrait mode. So when you are just you are just hello.
Hello. Yes, ma'am.
You have done some mode because of that. It's looking like blur only. Um, Actually, I want to know about the assert property. I want to know in respect of the assert property using the assert property. Hello,
Hello.
am I audible?
Yes, ma'am. Yes, ma'am.
Yeah, I'm saying that I want to know this answer with respect to the assert property. Do you know about the assert property?
Assert property is similarly case if statement, like in normal, ma'am, case conditional statement, like if they assert some condition, if it's true, the below statement will execute, else it's error, ma'am.
So can you write it in the form of assert property?
Assert property
Yeah,
for RAM, ma'am.
yeah. Read after write. It's not visible. It's not visible.
Not visible, ma'am.
No. You have done some mode because of that it's looking like blur when you focus something on it.
And
I think you have selected the portrait mode.
I don't know where to change, ma'am. I change, ma'am. No filter, no, ma'am.
No. So can you like zoom out?
Yeah,
Zoom
okay.
out. Zoom out. Zoom out. Not in. Like out. It's not visible. Can you put it in front of your face? Like yeah. No.
Visible, ma'am.
No. No. It's not visible. Um. Oh. Okay. So it's not visible. So leave it. Now I will move to the next question. So the answer would be like the assert property at the rate posage clock and
Yes, ma'am.
disable if reset. Then write enable will be triggered when the delay when we can write any delay. So after that read data is equal to write data.
Yes, ma'am.
Yeah. Okay. I think you have written so much lines. I don't know why. So why you have written the so much lines?
It full operation memory.
Okay, okay, okay. So, okay, fine. So, we can move to the next question. Do you know about the UVM component utils?
UVM component utils, ma'am.
Yes, what it does.
UVM utils is used in writing code. UVM component utils inside parentheses the class name we wrote, ma'am. I
No, it
don't
there is a main point. I want to listen that only.
I don't know exact one, ma'am.
Okay, so it is used for the factory for object creation, like automation and configuration. Factory is the main word. Factory for the object creation.
Yes, ma'am.
Okay. So, can you explain me the TLM? Know about it?
TLM analysis code, ma'am.
Yes, yes.
These
You
are
show me it in a diagram if you can. No, no. Okay, leave it.
port is connected between sequencer and driver and scoreboard and monitor, ma'am. It connect, I think, in
TLM analysis port. You're talking about the TLM analysis port.
yes, ma'am.
Okay. What you have said?
Connect between sequencer and driver and scoreboard and monitor, ma'am. Between,
So, is it unidirectional or bidirectional?
I think it's it's unidirectional, ma'am.
Okay, that's correct. Do you know about the randomization?
Yes, ma'am. Randomization, no, ma'am.
Okay, so you know about the difference between the RANSI and RAND.
Yes, ma'am. I know, ma'am.
Please proceed.
It's the it's a keyword used to randomize the stimulus variables, ma'am. In a rand, it generates stimulus randomly. In a rand C, cyclically randomized, ma'am. If, for example, bit 3 is to 0, 3 is to 0 means 4-bit variable A. It After completing 16 variables, it doesn't repeat again, ma'am. Randomize cyclically, ma'am. After one cycle complete, then randomize, ma'am, and repeat the data, ma'am.
Okay. So correct. So do you know the difference between the always underscore comp and always underscore ff and always
Yes, ma'am.
underscore latch?
It's all procedural block used in system Verilog. Always com is used for combination circuits. Always FF used for flip-flops, ma'am, in
Okay.
sequential circuit.
And always latch.
For latches, ma'am.
Do you know about the latches inferred?
Ma'am?
Latches inferred.
Latch inferring, ma'am.
Yes.
Latch inferring means uh, in conditional statements, if the given value is not mentioned in the combination, it's take a previous value, ma'am. Return previous value.
Okay. Have you written any code with respect to it?
Can I write, ma'am?
Have you written any code with respect to it?
Latch inferring, ma'am.
Yes.
I written, ma'am.
So you got the error about the latch inferred unintentionally or anything else?
Latch inferring, no, ma'am. It take previous value data, ma'am. Previous output, it return, ma'am.
Okay.
In case of default is not there, it take previous. In if default is there, it take default value, ma'am.
Okay. So do you know about the mode ports?
Ma'am, yes, ma'am. Mod port give directions, ma'am. Uh, for example, in consider an after it has A, B, and sum and carry. For DUT, A, B is input, sum and carry is output. For test bench, A, B is output, and sum and carry is input. This mod port give directions to the DUT and test benches.
Okay. So what is the difference between the virtual and pure virtual?
Virtual and
Pure virtual.
um, virtual. We can write virtual in virtual class in both class and virtual class, but pure virtual you must write in virtual class only, ma'am.
Means?
I mean, you're asking about virtual methods and pure virtual methods, right, ma'am?
Yes.
Virtual methods we write in virtual class and class, ma'am, but pure virtual methods write in virtual classes only, ma'am.
So can the virtual can be overridden?
Overridden.
Yeah.
Virtual, ma'am, virtual class and directly not access. We have to extend and then use the handles, ma'am, properties. Directly we are not access, ma'am.
Okay. You have done the APB protocol.
Then ma'am, I know some basic about.
Okay. What is the PSLV RR in APB?
P
PSLV ERR.
SLVERR, ma'am.
Yes.
P P select, SLV. Don't know, ma'am. Exact. Ma'am, slave error. Yes, ma'am. I mean, it's a signal sent by slave to master. If there any error occur, it send one, ma'am. No error, it send zero, ma'am.
Okay. So how do you insert the wait states in APB verification?
I don't know, ma'am.
Do you know about the P ready?
P P ready, yes, ma'am. It is ready to accept. It's sent one. It's zero, ma'am.
Okay, if both P select and P enable are high, but P ready is zero. So what will happen?
Ma'am, P.
If both P select and P enable are high,
Hey,
okay, so
uh,
but P ready is zero.
data transfer not happen.
Okay, so when it will happen?
Period is 1.
Okay. So do you know about the maximum transfer within ABB?
Hmm?
Maximum transfer width in APB.
A maximum, I don't know, ma'am.
Okay.
System timing, less
Yeah. You know about it? Or
basic one, I know, ma'am. Basic.
can I ask question from it?
Yes, ma'am.
So what is the propagation delay?
Propagation delay is the time between time required to send data from input to output, ma'am. Time duration.
Okay, so what do you mean by the setup and hold time violation?
Setup and hold time is setup time is the minimum time required to input stable before active clock heads. Hold time is after clock heads minimum time required to stable the input, ma'am.
You have done the UART protocol.
No, ma'am.
Okay, so in STA, what is uncertainty?
I don't know.
You know about the skew rate.
Skew rate, ma'am. Minimum. I think I know, ma'am. Forgotten, I know, but I forgot, ma'am.
Okay. Do you know about the range in two's complement and one's complement? What is the range?
One's complement 2 power n minus 1, 2 power n minus 1 minus 1 to 2 power n minus 1 minus 1, ma'am. In 2's complement 2 power n minus 1 1 minus 1 to 2 power n minus 1 minus 1, ma'am.
Please repeat it for two's complement.
2 power n minus 1
Hmm.
to 2 power n minus 1 minus 1, ma'am.
Okay.
Minus starting from minus to plus, ma'am.
In case of unsigned integer,
0 to 2 power n, ma'am. 0 to power n minus 1, ma'am.
okay. Can you define the finite state machine
Yes, ma'am.
and
It's a finite state machine.
Mealy and Moore
Yes, ma'am.
also?
There's two types, Mealy and Moore, ma'am. Mealy output depend on current state and current input, and Moore statement output depend on only current state, ma'am. Mealy add one extra state, ma'am. Moore one lower statistic requirement.
So, how you have made the 32-bit Vedic multiply using Verilog? Can you explain it?
I mean, it's a hierarchical approach, ma'am, from 1 bit to 32 bit, ma'am. Uh, like for 32 bit, I use 4 16-bit Vedic multiplier. For each 16-bit, 4 8-bit, each 8-bit, 8-bit, 4 each 4-bit, each 2-bit, each 2-bit is 4 single bit.
What is the Vedic multiply exactly? I want to know that.
Vedic multiplier is the ancient technique to use to multiplication for a large number. It's like
So,
a vertically and crosswise multiplication.
so like we can give the inputs to your code and we can get the output.
Yes, ma'am.
So how the Vedic multiplier is defined there? Like if we generally do the input, give the input, we'll get the output only, right?
Yes, ma'am.
So what's the difference like in your
And
code?
in our code, a number of AND gates will reduce, ma'am. Circuit will reduce, ma'am.
Oh, okay.
Uh, Then power consumption is less and area is less. Performance speed fast, ma'am.
So you have used the Urdhva theory.
Yes, yes, ma'am. Yes, ma'am.
Okay, so
Rudva,
the
yes, ma'am.
okay,
Rudva means vertical, Ram means horizontal, crosswise, ma'am.
okay.
Multiplication.
So why you have used the recursive hierarchical design? Like
Ma'am,
why you have used the recursive hierarchical design?
ma'am, because we split the data into small part that calculation will be simple, ma'am. By hands also we made easy calculation, ma'am.
And what can be the maximum bit with your design can handle?
Hmm?
What can be the maximum bit width which your design can handle?
A maximum bit in 32 bit Vedic multiplier require 32 bit
Okay.
maximum bit, ma'am. Like increasing this, yes, it will increase the input data, ma'am.
So have you faced any challenges using making these 32-bit implementation?
Uh, yes, ma'am. In the in the, I studied the research paper about 32 Vedic player. Uh, it start from the 2 bit to 32 bit, ma'am. 2
Okay.
bit is they use 2 bit as normal calculation. First, they use 2 bit normal multiplication. Then they apply the Vedic multiplier methods, ma'am. It
Oh,
consume this also consume more circuit complex, ma'am. That's why I use 1 bit Vedic multiplier, ma'am, using a AND gate, ma'am.
oh,
It reduce the circuit complexity and give more performance, ma'am. Yes, ma'am.
procedural,
Assignment
procedural and continuous. What is
assignment,
the
ma'am.
difference? Yes, what is the difference between them?
Ma'am, procedural is used in always an initial block inside always an initial block, ma'am. It's s- in that there are two types, ma'am. Blocking and non-blocking, ma'am. Blocking symbol is equal. Non-blocking symbol is less than equal, ma'am. Blocking assignment it block the other statement until it execute. In a non-blocking assignment, concurrently it execute, ma'am. In continuous assignment, we use assign keyword to assign the expression, ma'am, values. Ma'am, the output variable must be reg in procedure. In continuous assignment, it must be wire, ma'am.
Do you know about the duty and test bench?
Yes, ma'am.
Um, can you show me the how they interact, like how the duty and test bench can interact? Okay, so don't show me like because it is look like blur, but you can just explain me.
I mean, generally, ma'am. In Verilog.
Yes, yes, yes.
Ma'am, design design output is connected to test bench input as an input. The test bench output is connected to design input, ma'am. This is how the design is, how the circuit and
Test
okay.
bench.
Design design output is connected to test bench input. Test bench input is connected to design output, ma'am.
Oh,
Array area was connected, ma'am.
okay, so at what time initial block executes?
I'm at 0, ma'am.
Okay. We know about the pipelining concept.
Yes, ma'am. Yes, ma'am. I know. It's parallelly execute one.
What? Parallelly?
And its pipeline means one after one. Yes, ma'am.
Okay. So, what are the tasks and functions in Verilog?
Display task difference system task function asking ma'am.
Task and function.
And difference ma'am.
Yes.
Um, ta- Task is not synthesizable, function is synthesizable ma'am. Uh, in task allow uh, both blocking and non-blocking assignment. Functions allows only blocking assignments. Uh, Function must have one input argument, and it allows only input arguments only. Function allows either zero arguments or input in arguments is allow ma'am. Function return only one output. Task may return task doesn't return anything ma'am. Functions do not allow delay statements, but task allow ma'am. Mm, but we ma'am we if you want to call for function, we can't call task inside function ma'am. We can call function inside task ma'am. When we call function, we have target like a is equal to function name argument. In task, no need of target, direct task name and arguments ma'am.
Okay. What are the types of delays in Verilog?
Delays in very long ma'am.
Yes.
Gate delay, inter assignment delay, intra assignment delay, net declaration delay.
What do you mean by the inertial and transport delay?
Inertial delay is inter assignment delay. Transport delay is intra assignment delay ma'am.
Okay, what they please describe them.
In inter assignment delay, first delay output is equal to expression ma'am. In intra, our target is equal to delay assignment and expression ma'am. In inter assignment delay, first output will expression will execute ma'am. After delay, the updation will happen. But in intra assignment delay, wait for time delay, then execute and apply ma'am. Intra assignment delay doesn't block the delay is not count for any begin and block ma'am.
Okay. So what do you mean by the delta delay?
Forgot ma'am delta delay.
Okay. So delta delay are the event schedule at the same simulation time occur in our delta cycles to avoid the race conditions, right?
Yes, ma'am.
Okay. Can you explain me the difference between them, which I have written in the chat box?
Yes, ma'am. First one is the uh, inter assignment blocking assignment inter ma'am. Second is non blocking intra assignment delay ma'am.
So when
Blocking
they will
inter
execute, like,
ma'am. Inter assignment will execute 5 ma'am at 5 delay. First execute inter-assignment delay, then at the end of the time, second one the intra-assignment delay execute ma'am at the end of the time. In either this one, first one is in active region, it's NBA region ma'am.
okay, I think I think that's all from my side. Thank you.
Yes, ma'am.
Do you have
Thank
any questions from me?
you. Questions. I think I need to improve in UVM and protocols, ma'am.
Yes,
I
yes.
didn't do well in UVM and protocols. I must study, ma'am. I will take.
Yeah. Also, I think that you must do the basic project like
Yes, ma'am.
GNOME,
Yes, ma'am.
SPI.
I know only basic. I go through it, ma'am.
Yeah, yeah.
Yes, ma'am.
And you have knowledge in which you have done you, and you can also improve your knowledge around doing other projects also. You can do more project
Yes, ma'am.
also.
Yeah. Yes,
Yeah.
ma'am.
Okay.
Okay, ma'am.
That's all.
Yes, ma'am.
Okay. Thank you.
Thank you, ma'am.